Hello everyone, welcome back. This is Engineer Hussein Mwasapi. Alright, so in this video we'll be looking at another session or question in your NQ or NS physics exam. Alright, so before we begin, don't forget to like and subscribe, as well as hit the notification bell icon and share to your friends. So the question says the resultant displacement D of three successive displacements is 100. Okay, let's try and collect data from the information here. So I've been told that the resultant displacement, which is let's call it dr, d sub r, of three successful displacement is 100, and that it's measured from the origin at an angle of 35 degrees above the positive x-axis. So this is 100, and it's of three displacements. All right, so it's for three displacements, and it's measured from the origin. So from origin, and this is done at an angle. So it's at an angle of 37 degrees. Okay, so this is above the x-axis, above the positive x-axis. All right, so that's the information we have. Okay, so other than that, we've been told that D1 is having a magnitude of 100 meters, and it's along the negative x-axis. So this guy is along the negative x-axis. All right, and D2 is 200 meters, and this guy is at an angle of 150 degrees. Okay, so I've been told to determine the magnitude and direction of the third vector, D3. So D3, we don't know. What of the angle? The angle, we also don't know. So let's try and find the magnitude and the angle. So in most cases, what we do is, firstly, this is a vector analysis question. So we know that the resultant displacement, which is dr, is as a result of d1 plus d2 plus what? D3. Now for us to find d3, we need to resolve all these vectors into their x and y components. So let's try and resolve them. Let's start with d resultant. Its magnitude is 100. So this one, it says that it's from the origin at an angle of 37 degrees above the positive what? X-axis. So we know that the size is that. So resolving this guy, d resultant will be, remember, it's going to be 100 cos 37, that is in the I, plus 100 sine 37 in the j. So d resultant will give us, if we punch that on our calculators, we'll get 79.8635 something, that's say in the I, plus 100 times sine 37, that will give us 60.1815, and it keeps on going, that's in the j. Okay, so if I round off to two decimal places, so sorry about that, so dr, I'll have it as two decimal places, that would be 79.86 in the I plus 60.18 in the j. That's for my d resultant. Okay, so that's d resultant resolved. Let's also try and resolve d1. Now d1 is only acting along the negative x-axis, according to the question, along the negative x-axis. Therefore d1 will be resolved as negative 100 in the I plus 0 in the j, because we literally have nothing in the j, it's just acting along the negative x-axis. Then d2, okay, so we can do d2 where there's space. So d2 is 200. This is the information for d2 that we got. It's 200 and it's above the positive x-axis at 150. Okay, so d2 is having a magnitude of 200. So from the origin, its angle is 150 and the magnitude is 200. So resolving d2, we'll get d2 to be 200 cos 150 degrees, that's in the I, plus 200 sine 150 degrees in the j, like that. So d2 will be equivalent to, if we punch these values, we'll get minus 173.205, because I'm going just like that, in the I, plus 200 times that, you get 100, that's in the j. So rounding this off to 2 decimal places, this will give you minus 173.21, that's in the I, plus 100 in the j. Alright, so then we also need for d3. So for d3, we don't know what d3 holds. So for d3, we'll just say, okay, d3 is x in the I plus y in the j, because we don't know. Alright, so we have resolved all the vectors that we have. And if at all you have issues resolving these vectors that we have, you can always go to, you can check out my video on resolving a given vector into its components. It's among one of my playlists that I've actually listed on the channel. So just check it out and you'll understand how to go about it. I know at first glance it might look like a handful, but with a little bit of practice, you get a hang of it. Okay, so we know that d resultant is d1 plus d2 plus d3. So writing this same notation with our components, we can say, okay, d resultant is equal to d1 plus d2 plus d3. So d resultant is having the components of the resultant that we found here, which is 79.86 in the I plus 60.18 in the j, being equal to d1. d1 is having the components here, which is negative 100 in the I plus 0 in the j, plus d2 is having these components here, which is negative 173.21 in the I plus 100 in the j. Okay, I'm not really having space this side, so I'm going to erase these values this side. Hope you wrote them down somewhere. Okay, so I'm going to write now d3. This one here should be plus, but we go for d3, which is x in the I plus y in the j. Alright, so now that we have done that, we can get the I components separately. So let's sum up the I components and see what we can do. So using this equation, let's get the I component in the resultant, which is 79.86, being equal to the I component in D1, which is minus 100. Then the I component in D2, which is minus 173.21. Then the I component in D3, which is plus x. Then let's solve for x. If we add up these two entities here, we'll get a value of minus 273.21, then plus x, then we'll have 79.86. So solving for x, what we'll get is x being equal to 79.86 plus 273.21. Then x is equal to, if we add these two values, we'll get 3 53.07, and this will act in the I. So that's the I component for D3. Then we do the same for the J component. For the J component, we do the same. So for the J component, I'll get the J component in the D resultant, which is 60.18 being equal to the J component in D1, which is 100. No, it's 0, so I have 0. Plus the J component in D2, which is 100, plus the J component in D3, which is Y. Then solving for Y, we have Y being equal to 60.18 minus the 100. So Y is equal to, if we subtract, we get minus 39.82, and this will act in the J. Now this simply just tells us that the components of D3 are 353.07 in the I minus 39.82 in the J, like that. So now that we have found the components, the question is not asking us to determine the components, rather the magnitude and the direction. So we can find the magnitude. So the magnitude of D3 is equal to the root of 353.07 squared plus minus 39.82 squared, like that. So I'm going to erase this portion and a bit of this, like that. So the magnitude of D3 is equal to, if I root those values that I'm having there, we'll have 353, it's supposed to be 355. All right, so that's what we're going to have, 355. All right, so just a moment, let me just confirm something. 353.07 squared plus 39.82 squared, then root that. Yeah, we get 355. So getting 355.309518.3. Rounding this off to, I guess, 2 decimal places. I prefer 2 decimal places. I don't know why, but I prefer it to any other. But anyway, it depends what you've been given in question to follow. So it's going to be 31 meters. So I'm having my magnitude. Now I need to find my direction. Now to find the direction, remember, let's use a tan theta equation. Okay, so just erasing this. Okay, so to find the directions, I'm just a direction. So it's gonna be tan, so theta is equal to tan inverse of the J over the I component, which would be, so we're having 39. It's 39.82 over 353.07. So theta is equivalent to 6.43635336 degrees. So theta, let me call this theta prime, is equal to 6.44 degrees. Now the reason I'm calling it theta prime is because it's just too small. It's just too small. It doesn't really add up. So why is it not adding up? Because if you look at the position of D3, if I were to put this on a Cartesian system, I'm moving in the positive I, but going in the negative J. This means that I'll be moving in the positive I, but negative J. So I'm not in the first, not in the second, not third, but in the fourth quadrant, which means that theta is equal to 360 minus theta prime. So theta is equal to 360 minus 6.44, and theta is equivalent to 353.56 degrees. And this is literally the direction of the third vector. Therefore, in most cases, you can just write your third vector, which is d3, to be, so you have the magnitude as 353.31 meters, measured at an angle of 353.56 degrees. So this is our answer. All right, if you have questions, you can always reach me out on WhatsApp on the line 077-149-5252. Remember, slow progress is better than no progress, and let's strategize before becoming a statistic. And let's try and push for the higher plus.